Welcome to the video of trig laws, and we're going to be talking about the laws with non-right triangles. The key points we're going to cover, we're going to talk about the law of sines, the law of cosines, and then we're going to do some application problems. But before we start that, I want to kind of do a little background before we talk about the actual laws. First of all, if we had a right triangle and we were looking for an actual side of this right triangle, we know that Pythagoras' theorem works, that if this side was A, this side was B, and our hypotenuse was C, we could say A squared plus B squared equals C squared to find the length of any of the sides. Okay? So that's one thing you know. Another thing we know that in any triangle, okay, if you had any triangle, that when we label these, all these three angles add up to 180 degrees. I'm like, okay, yes, I know that too. Okay. Now, to refresh your memory, recall that the hypotenuse of this right triangle is the longest side of the of that triangle because it's across from the largest angle. So another thing that you know about, if I was going through and telling these angles, is the longest side of the triangle is across, and I can't spell across right, sorry, 1C, is across from the largest angle. And also, the smallest side is across from the smallest angle. And when I make the angle symbol, I just make this with the arc through it because it looks like a less than sign. All right. We also know in this right triangle, let's talk about basics, so we also know that SOHCAHTOA works. Sine, cosine, and tangent. So that's another background that you know. Well, the other thing is basically labeling. So I'm going to draw just any old non-right triangle, and I have these angles, A, B, C. When I label the angles, notice they're capital letters, and I'm writing them on the outside. Then when you determine what the sides are, we usually use little letters. So this is a small a, small b, and a small c. So that you see that the lowercase, that's how you label it, and it just makes it easier when you learn the laws to remember this little background information. Okay, so let's go and look at the first law, and the first law we're going to talk about is the law of cosines. And it's called the law of cosines because cosine is in it. And this is the pattern, and when I show you this, this is a pattern. The small or lowercase letters are the sides, and the large letters are the angles. So I'm going to kind of rewrite this because they used alpha, beta, gamma. So we'll call this a capital A because I want to make sure that this goes with what I just told you. So we're going to label this angle here with a capital A, a capital B, and a capital C. And across you'll see a lowercase a, which I think is down here further. Yep, there's a lowercase a, and then you have a lowercase b and a lowercase c. So we'll just do it that way to keep everything the same. Now the pattern for the law of cosines is c squared equals a squared plus b squared minus 2ab cosine c, which looks really similar right to here. It looks almost like the Pythagorean theorem, but there's more added to it. Now let's look at the pattern. The pattern can also be written the following ways. Okay, and usually when you put it here, it's what you're looking to solve. So notice this c squared's here, and then I have a capital cosine c, and then the other two are here. So the pattern, I could say, is a squared equals b squared plus c squared minus 2, repeat these two, bc, cosine of the angle A. Same pattern. Or I could write this as b squared equals a squared plus c squared, the other two sides, minus 2ac cosine b. So that's just what the pattern is. You can write it 3 different ways. Or you could use different letters if your triangle has different letters. So we want to solve this triangle. When they say solve this triangle, I want you to remember that we have to find 3 angles and 3 sides. So that's 6 things. So you look at what they have, and when we get done, we're going to label everything to see what they gave you. Let's see what they gave you. So they got B is 84, so that's a side. That's a 4. C is 65, so they gave us a side, and they gave us the angle alpha, or in this case A, is 36.4 degrees. Okay? So right now, if I was going to label all the sides, A, B, and C, and angle A, angle B, and angle C, because they want us to find everything, I have some information already. I know B is 84. I know C is 65. I know angle A is 36.4 degrees. So this helps because now I only have to find 3 more things. All right. So I look at the information I have, and usually when you use the law of cosines, you look for side angle side to see if that is possible to use. And if you'll see, I have information here, side, the included angle, and this side. So it looks like I can use the law of cosines. So what I am going to do is, since I know the angle A, so I'm going to look up here, I'm going to find the side opposite here. So we're going to set it up using this formula. So I'm going to say A squared, that's what we're going to look for, equals B squared plus C squared minus 2BC cosine of the angle A. Now let's go through and plug in what we know. So I have A squared equals 84 squared plus 65 squared minus 2 times 84 times 65 cosine of 36.4 degrees. And please make sure your calculator's in degrees, or this isn't going to come out. When I put all this in my calculator, just as it is, like you could do, I have A squared equals 2491.559733. Then I take the square root of that. So A comes out to be 49.91. And here everything's just two places, so I'm going to round that to 50. So now I know this A, side A here is 50. Now, if you look at this, the smallest side is 50, so this angle 36.4 is across from it, so that should be my smallest angle. So if I find another angle, that will be cool, and then I can subtract it from 180 to find the third one. You don't have to do this over and over again. So now let's look to see if we can find something else that we need. And I see that I don't have any more angles to use, so I'm going to have to figure out an angle using one of the sides. So how about we look for angle B? So I'm going to say B squared. We could have done C, but we're going to do B squared equals A squared plus C squared minus 2AC cosine B. So B squared is 84 squared equals A squared, which is 50 squared, plus 65 squared minus 2 times 50 times 65 cosine B. So I don't know the angle. That's what we're looking for. Now, when you go to do this, let me give you a little hint. This whole thing is a term here. This is a term, and this is a term. What I want you to do is take this on this side and subtract it and that one. Do that first, and then you're going to divide it by this multiplied out. So right now I have, if I do 84 squared and subtract 50 squared and subtract 65 squared, I get 331 equals negative 2 times 50 times 65 cosine B. Now I multiply this together, so I have 331 equals negative 6,500 cosine B. All right, and then I'm going to divide by negative 6,500, so I actually have cosine B equals 331 over negative 6,500. Now, in order for me to figure out what the angle is, I've got to actually put the inverse in. So I'm going to do inverse cosine of 331 over negative 6,500. And when I do that, I get 92.9 degrees. So we can round that to 93 degrees. And now we'll tell you how to round in class. So now I know B is 93 degrees. So I'm going to put this here, and I'll label it on my picture. Okay, and if I look at it, 93 is bigger, and so 84 is the largest side. So I bet you angle C is going to be between these two. And if I go through and I actually add these up and subtract from 180, I get that angle C is 50 degrees. And that is between 36.4. So now I've solved the triangle. That's what they mean by solving the triangle. Find all three sides and all three angles. So that's a review of the law of cosines. Now let's talk about the law of sines. Now the law of sines is also a pattern, and look, you see two equal signs. You're like, when do I ever use three equal signs? Well, you won't. You'll either use these two together, or the ends together. So you're only going to need two. Well, the law of sines is saying if I have the angle, the side opposite over the sine of that angle, it equals the sine opposite over the sine of that angle. So I can kind of pick whatever I want. Again, it's a pattern, okay? And when I do this, I always try to use law of sines first because I like it better. So we're going to label this triangle again. This is angle A, this is angle B, this is angle C, just to make things a little bit easier for you. And let's look and see what they have us, because we have to solve what they have for us, because we got to solve this too. So I'm going to stack and rank. So we have A, we got to find all three sides, and we have to find all three angles. This just organizes me, okay? So they said alpha is 43 degrees, so that's my angle A. So that's 43 degrees. And beta, or B, is 72 degrees. Oops, sorry, it's 0.0. And then C, angle C, it's easy to find because now I have two angles. If I subtract it from 180, I find that angle C is 65 degrees. So this is 65. We should probably say 0.0 degrees because that it is. So now I have all three angles. Now notice up there when we did the last slide, we only had one angle and more sides. Here, look at all the angles we had, and they only told us one side, which they told us A was 5.40. So you'll notice the difference. I can use law of sines because I have more angles to work with. So let's try to find, just for the heck of it, side B first. Okay? So I'm going to do the one I know. I know 5.4 is side A over the sine of A, which is sine of 43 degrees, has to equal whatever B is over the sine of whatever angle B is, which is 72 degrees. When you do this, you kind of cross multiply. I shouldn't say kind of, you do cross multiply. So I have B sine 43 degrees equals 5.4 sine 72 degrees. And then I'm going to divide by sine of 43, and when I do, I get B to come out to be 7.53. So now I know that side. And we know A, so I should put that there. And 7.53 for B. Now we got to find the other side. And you can't add it from 180 or whatever. You're just going to have to do the law of sines again. So I'm looking for side C. So I'm going to use the same ratio because it's what they gave us. So I got 5.4 over the sine of 43 degrees equals C over sine of C, which is 65 degrees. Now when I cross multiply that, I have C sine 43 degrees equals 5.4 sine 65 degrees. And then I'm going to divide by sine 43. When I do, I get C to get 7.18. And so I label my picture, and I have solved the triangle. Now I always like to look to make sure that my sides and my angle work. So if I have the smallest angle is 43, is 5.4 the smallest side? Yes, it is. 65 is my middle, 72 is my largest. So it does work. So there is a brief review on how to do law of sine and cosines. Now, I want to do a couple application problems with you because part of doing the application problems is drawing the correct picture so that you can do this, all right? So, I have, suppose the angle of elevation to the top of the hill. Now, a lot of people don't know where to put that. Angle of elevation is if you were here, okay, so here's me, looking at, so here's your hill, looking up at the top of the hill. The angle of elevation is this angle right here, okay? So when we go to draw this, I'm going to show it kind of that way. But they want to know the angle of, they said, suppose the angle of elevation to the top of the hill is 42.5 degrees. If you move 48 feet further away, the angle of elevation is 31.4. How high is the hill? So let's do the hill. So here's our hill, okay? And I'm going to draw my little triangle here, a right triangle here. So this is my hill, I'm going to stand here. So if I'm standing here, the angle of elevation is 42.5 degrees. Okay. Then they said if you move further away, 648 feet. So I'm going to move further away, right here. And if I look to the top of the hill, sorry, it's kind of wiggly here, you are going to have an angle of elevation of 31.4 degrees. Okay, which makes sense to me because the further away you are, the angle is going to be smaller. So they want to know, all right, how high the hill is. Well, that's nice to know. So I'm thinking if I can get into this triangle here, which is a right triangle, I could even use SOHCAHTOA or adding all the angles up to be 180. So there's a lot of things you can do. But before I get in there, all I know right now is an angle in this right triangle. So this is a triangle, if you will, and it's not a right triangle. So let's kind of put in everything we know. So I know this is 31.4 degrees. I can actually figure out what this is right here because these two add up to 180. And I know right here, so this is going to be 137.5 degrees because these two angles are next to each other and they form a line, so it's 180. So that makes this angle up here 11.1 degrees. So I found all the angles there. Okay, and I do know one of the sides. So if I have more angles than sides, I'm thinking, oh, I could do the law of sines to figure out this side right here. Okay, let's call this, I won't call it, we'll call it A. I can find A by doing that. So I'm going to say A is to the sine of 31.4 degrees, as, and the only side we know in this triangle is across from the 11.1 is 648. So I'm going to say as 648 feet is to the sine of 11.1. So if I cross multiply, I have 648 sine of 31.4 degrees equals A sine of 11.1 degrees, and then you divide by that. I find that A comes out to be, excuse me, A comes out to be 1753.64 feet. So that's what this is right here. I'm going to kind of highlight it. So I just found this side right here of my right triangle, and I found it's going to be this much. Okay? Now, I'm very, very happy because I know what this is. Well, since this is a right triangle, I can use SOHCAHTOA. So I've said, all right, here's my angle. I'm looking for the hill, which is opposite, and this is adjacent. So I can actually say the sine of 42.5 degrees is equal to opposite the hill, which I don't know. Okay, we'll call this x, if you will, over A, which is 1753.64. And when I cross multiply this, I have x equals the sine of 42.5 degrees times the 1753.64. Actually, I should have put that in front. So when I do that, the hill comes out to be 1184.74 feet. So that is how high my hill is. Okay, so I've solved for it. One more word problem or application. I like this one. You have two fire stations and they're located 25 miles apart at point A's and B. So I'm going to say here's A, here's B, and they said they're 25 miles apart, so I do that. They said there's a forest fire at point C, and they said if angle CAB, so I'm going to say point C is over here, and I'm not going to make it not a right triangle, so this is point C. They said if point C, so here's a fire over here, so we got a fire going on over here, all right? There's a fire over here in this over here, okay? So now I want to go through and figure out which fire station is closer. Is it fire station A or is it fire station B? Okay, and then how much closer is it? Well, they said if this angle right here, okay, angle CAB, oh no, that's not the angle right there at all. I apologize. Angle CAB is up here. Is 54 degrees. And CBA, which is this angle over here, is 58 degrees. Which station's closer? Well, I can figure this out by adding those two up, subtracting them from 180 is 68 degrees. So I have a lot of angles, so I'm thinking law of sines is going to be something we're going to do. And we want to see which fire station is closer. So basically we're going to be looking at trying to find little a and find little b and see which one's closer. So let's find a first. So I'm going to do 25 over the sine of 68 degrees equals a over the sine of 54 degrees. I have, when I cross multiply, I have a sine of 68 degrees equals 25 sine of 54 degrees. Divide by the sine of 68, I get a is going to be 21.8 miles. So now I know this is 21.8 miles away. Okay. Now let's do the same with b, so we can see how far away that is. So I'm going to use the same ratio. 25 is the sine of 68. And I usually try to do that, use what they gave us in the word problem. And I'm going to find b, okay, is to the sine of 58. Cross multiply and do my dividing. I end up coming out with b is 22.9 miles. So this is 22.9 miles. So my picture doesn't really show this, but fire station A is closer. All right. So now I know A is closer. But that's not what they asked me. They did ask me that, but they said how much closer. So I actually have to subtract. So I do 22.9 minus 21.8. So it's really about 1.1 miles closer. So that gives you a little taste of some applications and to refresh your memory on the law of sines and cosines.